No questions. Everyone's going to raid.
So myth number 2, storage arrays need large amounts of cache to keep the I/O off spinning media. Processes like deduplication hurt performance further due to large amounts of CPU and disk I/O required to remove redundant data. Neil, I'll let you take this one.
Sure. So back well, I shouldn't say back in the old days. A lot of storage arrays, the way they do it, they have large amounts of cache, big, terabytes of cache, because they want to keep things off of spinning media. That's probably the worst penalty, and that's what we just talked about is whenever those disks spin up, you lose performance and you get penalty there. So what storage vendors have done is they've incorporated large amounts of cache into their box, so that a lot of things can get stored in cache. You don't have to go back to the spinning media. So your retrieval rates and your writing to the drives is much faster. So a lot of folks say, well, NetApp, that's what your NVRAM card's for, right? No, that's actually not what it's for. What we do is we've got our RAM in the box, which actually isn't a lot of space, and then we have our NVRAM. And the NVRAM, its only purpose in life is to copy stuff to disk if the power goes out. That's really all its job is. And you might go, well, what's the point of that? That seems an awful waste. Well, because we do this cool write caching and this write coalescing and basically what goes around in our waffle, a lot of stuff is in flux. It's in transit inside the RAM. So what happens if you have a power outage? If we didn't have that NVRAM card, which is actually non-volatile RAM, if the power went out, everything that was being kind of thought about and was in memory would disappear. So we actually have that card in there. So if the power goes out, everything gets written to disk. So you don't lose any you don't lose any of your writes. So what does that mean? So let me get back to the question of we need lots amounts of RAM. So NetApp has done this because of the way that we write our ONTAP code with Waffle, all this cool write optimizations, and stuff is kind of being calculated with the parity as well. We like to call it is tetrising. So if you think of a game where you've got lots of little blocks coming down, if you just keep hitting down, down, down arrow, you're going to lose the game really quickly because the blocks don't fit very well. So what we like to do, and what has been optimized, is to fit these blocks together, and as Nick said, basically in a full stripe. So we try to coalesce them and be as efficient as possible. So before we ever even get to the RAM, before it actually gets sent there, we're actually doing all these calculations, and then it's actually then sent. So again, let me get back to the question of why we don't have to do this. So so basically, if you've got a lot of machines hitting this cache, typically you would need a lot of cache to handle this. But the way NetApp does it, again, with this RAM, and then we also have, so on the right side, let me back up. So my brain's going faster than I can keep up. So on the right side, we've got our cool Waffle technology, and basically it does all this coalescing. On the read side, we've got the RAM in the box. Now, if you need extra read capabilities, we have something called a flash cache card, which actually allows for caching of more reads. So basically, built into the box, you've got the Waffle, which helps with the writes. And then you've got the RAM that helps with the reads. But if you need extra, we've got also this card that gives you a little extra boost. So what does this card do for you? It basically gives you a little boost of extra RAM. And it gives you the capability of basically caching more reads. The cool thing about the flash cache card is that it's dedupe aware as well. So if I run dedupe and I shrink down storage, all of those reads that I've just done are now inside my cache. So you kind of get a 2-for-1 benefit there. So what we like to do is use less cache, but use it more intelligently. I guess I should have just said that right away, instead of just technobabble. Like I said, other storage vendors do it differently because of the way they actually write to drives. And that's not bad. There's nothing wrong with that. But the way we do it, we don't necessarily need that large amounts of cache. But if you are doing lots of reads and you do need extra caching capability, we do have the card.
So real quick, so I can jump in here. So you made some really good points, and I'm going to ask the audience here. So by and large, most of you interface with customers, correct? Right. So don't you always love when someone else goes ahead of you because it allows you to put all your thoughts in order?
Yes.
So thanks, Neil. So
welcome, Bob.
If I were to take what Neil said and all of it was correct, and I were to put it into a different point, or a different, say it a different way, a little more concise, is spinning disks provide you capacity. And that's the industry that we live in today. When you need performance, you start to look at solid state, right? Whether it's in disk or in, right? So like a NAND-based flash or a DRAM-based, PCIe type of device. As the disk drives, the spinning disk drives, the ones that we use for capacity, tend to increase in capacity. The customers are getting more value for their dollar. They're getting more storage density. What they're not gaining is any more performance. So the actual IOP, there's a finite set of IOPS based on the rotational speed and the disk drive type. And so my IOP per gigabyte or megabyte, right, as the drives become denser, I start to have a drop in performance. So I need the drives for capacity for cost. I mean, if cost wasn't a factor, we'd all just go out and buy solid state media and we'd all just leave this room. There's no value there, right? The customers always have to balance between achieve my business goals, which has a performance metric, and a capacity metric. So what we've done, and this is kind of the day and age, is we have lots of technologies to provide capacity at low cost and perform means or other mechanisms in the array based on solid state that allow us to have performance boosts. So we have NVRAM, which is solid state for the writes. We have system cache in the array. We have flash cache, which is a system cache expansion module. And we even have the means to put solid state drives in with the spinning disk drives to do a hybrid type of model. So we've got hybrid solid state and spinning disk drives all over the array. There's some fine tuning and mixing based on workload, what you would purchase or how you would deploy, but that's really kind of the end game. We then try to further the customer's value by having technologies like data deduplication. And if you think about data deduplication, that even contracts the amount of data on a disk drive even greater and actually increases the workload in terms of an IOP versus gigabyte perspective. The one thing that NetApp does that's unique in the industry is our system cache is dedupe aware. And so once I cache a block of data for a virtual machine, a database, a desktop, that block in cache will service every other request for that same bit of data that would be in the other database or desktop, right, or virtual machine's virtual disk file. So we're very unique in that perspective. So our goal is to always reduce I/O load on the spinning drives because they don't have performance capabilities anymore. Is that fair?
Yeah, and since you guys just heard me babble for at 11 o'clock, I'll put this in perspective. One of the things I talked about in my session was dynamic storage tiering, right?
Yeah.
And it's the new hot trend. This is essentially what we're talking about, how NetApp accomplishes it. So with system cache, NVRAM for the writes, and flash cache for reads, keeping those writes and reads in those things before they hit the back end and the spinning disk, which is where the penalty is,
Yep.
right? So that's how they accomplish their dynamic storage tiering with NetApp arrays. And maybe to put it in more perspective, like if you get an EMC, right, these big symmetrics arrays, they're going to just have like 64, 128 gigs of cache. So an insane amount of cache, and you're going to pay for it. Right.
You're going to pay for it, but they're going to perform, but they perform by brute force.
Right.
And that's what I was saying, like the dedupe
They
aware
don't
cache
have
gives us a lot of
intelligence, right? And that's where NetApp separates themselves from the crowd is, in your boxes, these FAS 3000 or 6000 series, there might be like 4 or 8 gigs of RAM is all.
Physical cache, yeah.
Right, and that's it. So how are they doing it just as well, and these other guys are doing it with 128 gigs of RAM? I think that's the intelligence we're talking about with coalescing and aggregating writes and using NVRAM, the onboard system cache, or a flash cache optional card, right?
Yeah, and so I think Nick made a really good point, and I would highlight this, which is every vendor makes an array that can achieve great performance. That's not what was in question, and he brought up names of other vendors, and I didn't mean to possibly take a swing at any of your other technology partners. That's not my goal.
I would.
I think if you look at your customer's objective, which is your customer has a budget, it's a fixed budget, right? Our goal from a storage partner is to provide you the greatest set of capabilities, and performance is one of them, at the lowest price point, so that when we come to market together, right, you can look at the budget that the customer pays for storage and say, I can do more with NetApp and thus sell more of my software, professional services, right? Make sure that the customer has the right solution versus if I've got to compensate for performance by buying big iron, which would be an example of what you shared.
Right.
And say, wow, I'm going to have to either have the customer move on his budget or drop some of my features so that we can get the performance. We want to help you succeed so that we all win.
And we appreciate that. Yeah. Now you can bring in CCS to give you a wonderful design.
So, raise your hands in the audience. Engaging with customers, I see a lot of the customers saying, I need SSD to solve the I/O performance when it comes to desktop virtualization. How many of your customers are telling you guys that today? And
a couple hands,
Couple
yep.
hands. And so, again, as the customer not really understanding how to basically architect the storage architecture for a desktop virtualization deployment. And I know for a lot of the sales teams that we've been engaging with at Citrix, storage is kind of the biggest roadblock to kind of accelerate these deployments beyond just the initial POC. And so by engaging with your counterparts at NetApp and working with us on the sizing and kind of the modeling that's necessary, we can help reduce that cost of storage per desktop dramatically, which then means more licenses for you guys and the deployment moving from that POC of